Hi GRE aspirants, welcome to this video. As you are aware, if you have been following this series, we are going through the Big Book Quant sections. This is going to be the 8th video in that series. So if you have been following along, I hope you are enjoying and you're solving the questions as you're watching the videos. That's the best way for you to derive value from this video as well as any other video as such. If you are new, I recommend you start in the order given, that is from test 1 through test 54. There are going to be 54 videos, and the number you will find in the icon of the YouTube video, or in the description also you will find the sequence of videos, or you could also follow them in that particular order by going through the entire playlist. There are multiple ways of doing it, but the idea here is that you go through the whole range of questions that are there on the GRE Big Book and solve them so that you understand whether you have any conceptual lapses or what are your test taking problem areas. So that's essentially the whole idea of this series, right? So on that note, let's get started. Okay, so as you can see, this is Big Book Test 4, Big Book Test 4, Section 5, 30 minutes, 30 questions. Let's get started. Quantitative comparison, question 1, 3x plus 4 is equal to 13. So that means 3x is equal to 9, x is going to be equal to 3, and 11 minus y is equal to 6. That means y is going to be 5. Correct? Let's verify these numbers. Always verify. If 3x is 9 plus 4 13, yes, that's making sense. 11 minus 5 is 6, that's making sense. Okay, but I don't have to compare x and y. Okay, be very careful. I have to compare 6x and 4y. So 6x is 3 6 are 18, 4y is 4 5 are 20, right? So I have to compare between 18 and 20. Obviously answer is going to be answer choice B. Okay, question 2. At noon today, A, B, C, D had exactly $1 apiece. Okay, so let's say if they had $1, each. During the next 5 minutes, A gave $1 to Betty, who gave $2 to Kathy, who gave $3 to Dot. Okay, so they are basically passing on amount of money. They are passing on increasing amount of money, right? Uh, let's see, let's just plot it. What happens after the first transaction? A gives $1 to Betty, so that means now we have A has 0, B has 2, and 1 1. Okay, but B gives $2 to Kathy. Okay, so B is giving $2 to Kathy, so that now we have 0 0 3 1, right? So this tier 2 is going from here to here, and then Kathy gives $3 to Dot, so we get 0 0 0. Okay, what do I have to compare? The amount of money Betty had left at 5 minutes past noon. So Betty has $0, as you can see here, and the amount of money Kathy had left at the end of 5 minutes. So that Kathy also has $0. So both of them have $0. Answer choice is C. Okay, I like how the sort of not circular but sort of kind of a cascade transactions scenario. I like that. It's straightforward, but it's very interesting the way these transactions are happening. Okay. All right. The number of prime numbers less than 50. Okay. So let's list down all the prime numbers less than 50. Keep in mind that 1 is not a prime number. That is a mistake many students do. 1 is not a prime number. So we start with 2. Then we have 3. Then we have 5. Then we have 7. We don't have 9. We have 11. We have 30. Okay, so that is how many? 1 2 3 4 5 6. So we have 6 prime numbers less than 50. Okay, number of odd integers greater than 5 less than 50. So that's going to be 7 9 11 and 13, right? Am I including 5 and 15? No, I have to pick numbers greater than 5, so 5 can't be included. Less than 15, so 15 can't also be included. So what are these numbers? 1 2 3 4. These numbers are 4 such numbers. So 6 versus 4, answer choice A. Okay, question number 4. 3 by 7 into 24 by 25 into 7 by 3. Okay, even the bracket doesn't matter because multiplication can be done without a bracket also. In that case, the 7337 gets cancelled. What I'm left with is 24 by 25. Okay. Both are positive numbers. The denominator is bigger. That means this number is going to be less than 1, whatever that number is, right? 0.96 actually is going to be less than 1. And I have 1 here. So answer choice B. Okay, let's look at question 5. X is equal to 17. Sorry, x plus 17 is equal to minus 8. Okay, let's subtract minus 8 from both sides. So I get x on the left side. 8 plus 17 is 25. So 25 on the right hand side. So x is equal to 25. So what is x? Sorry, x is equal to minus 25. Okay. X plus 8 is going to be minus 17. And I have the same number on right hand side also. So answer choice C. Okay. Let's see if this is correct. Yes, this is right. Okay. Always verify. You will have enough time on the GRE to verify, especially with negative numbers. Just be doubly sure. Okay. Let's look at question 6. RUT. Okay, on T I have this S and I have these different angles. All right, RT is perpendicular to SU. RT, okay, is perpendicular to SU. That means this angle is going to be 90 degree, as well as this angle is also going to be 90. So if this angle is 90 degree, so 80 plus y is 90 degree. So that means y has to be equal to 10, and x plus 75 is 90 degree. That means x has to be equal to 50. So I have 15 here, I have 10 here, right? Are the numbers are correct? Right. Okay, so answer choice A is the correct answer, right? Okay, question 7. Let me just get rid of this. Question 7, x is greater than 0. All right, x by 7, 5 by x. Okay, let's take x as 35. Okay, why am I taking 35? Because then I can divide by 7. Okay, I don't have to take 35. Okay, let's take, I don't have to, earlier I thought I have to divide both by 7 and 5. Okay, I thought it was something like divided by 7 divided by 5, but it's not divided by 5, it is 5 divided by 35. Okay, so 35 is going to be a bigger number, or the unnecessarily big number. Let's take a simple number. Let's start with 7. Okay, so x by 7, I get 1. This is left hand side, right hand side. X by 7, I get 1. 5 by 7, 5 by 7 is going to be 5 by 7 again is going to be less than 1. Okay, because numerator is small, denominator is big. So this is less than 1. In this case, I get answer as A. All right. Let me get a bigger number. If I take a bigger number, this is going to be more than 1. Let's say x is equal to 700. Just unnecessarily big number I'm taking so that I get an easy answer. So here also, what am I going to get? I'm going to get 100 on this side, and this is going to be 5 by 700. That's definitely going to be much less than 1. So that's again A. Now let me take a small number. Let me take x is equal to 1. Okay. Uh, we don't have to worry about the negative numbers because x is greater than 0, but always check for negative numbers. Okay, x is equal to 1. So here is going to be 1 by 7, and here it's going to be 5 by 1. Okay, so in this 7, 1 by 7 is obviously less than 1, and 5 by 1 is 5. So here I'm getting answer as B. Okay, so it took me 3 numbers to realize that how this is happening. Okay, always think about bigger numbers, smaller numbers, negative numbers, less than 1 numbers, less than 2 numbers, etc. But now I think we can stop because we have got definite cases where answers are differing. Okay, so the answer is going to be answer choice D. Relationship cannot be determined. Okay, question number 8, T and W. What are T and W? Okay, the coordinates of this. We know that in the XY plane, these lines are given to be parallel, sorry, perpendicular to the axis. Okay, that means if this line is, sorry, this point is 6 comma 6, right, and this line S perpendicular to x axis, any point on this axis, any point on this line is going to have the same x coordinate. That's what it means, right? So that means t is going to be 6. This 6, okay, right? This is going to be 6. In fact, this is going to be 6 comma 0. This is going to be 6 comma w. This is going to be 6 comma 6. Same logic here. This line is also parallel to, but this time it is parallel to x-axis. That means on this line, every point is going to have y coordinate as 3. Okay. So w is going to be 3, correct? This is going to be 0 comma 3. Right, this particular point. Okay, so t is equal to 6, w is equal to 3. This is 6 by 6 comma 3 actually. Okay, what are they asking? 6 versus 3. Answer choice A. Okay, see how are we able to do this? Because we know that these are 90 degrees, right? If these were not 90 degrees, then this logic will not work, right? Okay, question number 9. 3 raised to 3 into 125, okay, and 3 raised to 2 into 375. Okay, so let me express, just for ease of comparison, let me express everything in 3 raised to 2. Okay, so what do I get? I get 3 raised to 3 into 125. Basically that means 3 into 3 into 3 into 125. So I take this together, I get, and I take this together, so this becomes 3 raised to 2, this becomes 370. So 3 raised to 2 into 375, this is the same thing, right? 375. And incidentally, I have the same number on the right hand side also. Basically, that means that answer is going to be C. Okay. All right. Question 10. The volume of a cube with an edge of length 4 centimeters. Okay. So let's say this is edge of this is a cube with length 4. Okay. So what's the volume here? Volume is going to be base, that is 16. Area of the base, that's 16, into height. 16 into 4, 60. Column B, we have 4 times the volume of a cube with edge 2. Alright, so this is a smaller one with edge 2. The smaller base here is going to be 2 into 2, 4. And volume is going to be base into base area into height. That's going to be 4 into 8. That's going to be 8. Okay. And I have how many of such cubes? 4 cubes. So the total volume is going to be 8 4s are 32. So I have 64 on one side, 32 on the other side. Answer is going to be answer choice A. Okay, let's move on. Question 11. This is 100, this is y, this is x, this is 60. All right, I don't know if these lines are parallel. They are not parallel, at least visually. Okay, but let's see if there's anything I can do. I really don't have any information. The only thing I can figure out is that there are two triangles and this is a quadrilateral. Okay, let's see if I get anywhere. I'm not very hopeful because we don't know if these lines are parallel. How that affects is because, see, these could be parallel, this could not be parallel. If they were really parallel, okay, so let's say these were parallel and this was 100 degrees and this was 60 degrees, right? So then we could do something about x and y, right? If they are not parallel, we can't really derive anything, but let's still see what all we can do. If let's look at this triangle, right? Uh, let's see, this angle is P. All right, what can I say? I can say that, let's see, let me do it here. 100 plus x plus P is equal to 180. That much I know. That means P is going to be 80 minus x. This is 80 minus x. Similarly, this is also going to be 120 minus y. Okay, why? See, add them up. Y plus y minus y will get cancelled. 120 plus 60 is 180. Okay. Let's add all these angles together to get 360, right? Because it's a quadrilateral. So basically what do I get? I get 100 plus x plus 80 minus x plus 120 minus y plus y plus 60. All of them have to add up to 360. Okay. Interestingly, x and y get cancelled. And what do I get? 100 plus 80, that's 180, plus 120 plus 60, that's also 180. 180 plus 180 is 360. So I get the same equation, but I doesn't really help because x and y are getting cancelled. And basically what that means mathematically is that they could have any value. For every value this will work. So I can't really compare x and y. So the answer has to be D, right? See, this answer choice is D type of questions, right? We haven't had any D yet, I think, at least in this quantitative comparison. Uh, or was there a D? Yeah, there was a D here. Okay. Be very careful, right? Because that's kind of a rare thing. Only in one test we saw that there were so many questions with answer choice D, and I made a comment there that this seems to be a rare case, right? But the point is that whenever the answer choice is D, just be a little careful. This here definitely this is very straightforward. It has to be D because we really don't have any information. Okay, let's look at question 12. The sum of three integers is 51. Okay, let's say they are ABC. A plus B plus C is equal to 51. What do I have to do? The average arithmetic mean of three integers. The average is going to be A plus B plus C by 3. That means its average is going to be 17. Okay. What are those numbers? I don't know. Those numbers could be, also they have not said anything about whether they are same numbers, distinct numbers. Those numbers could be 17, 17, 17. Or those could be 0, 0, 51. Okay, those could be 51, 0, 0. Or there could be 16, 17, 18. We don't know, right? Or it could be 10, 10, 31. Any combination. The median of three integers. Okay, now what is the median? Median is when I put them in ascending order. Let's say in this case 0, 0, 51. Okay, let's not take this place because there are two values with the same number. Let's say a case where I have 1, 2, and 48. Okay, and I put them in ascending order. I am looking at the middle number. So is the middle number greater? How do I basically I have to compare the middle number with 70? What can I say? Here the middle number is 0. Here the middle number is 17. Here the middle number is 0. Uh, the middle number could be anything. Here the middle number is 2, right? So again, I don't know anything. That's because I don't have enough information, right? So answer choice D again. Okay, let's continue with question 16. Sorry, question 13. The area of the circular region with center O, okay, center O is 16 pi. So if the radius was, let's say, r, right? So the area is going to be pi r square. That's given to be 16 pi. That means r is given to be 4. Okay. So this is a circle of radius unit 4. Okay. The area of circle, this circle is 16 pi, and v, w, x, y, z. Okay, all these radii is, I think they have drawn, okay, at different locations, represent the lengths of the line segments. Okay, so these are all the lengths of different line segments, but their value is going to be 4 because the radius is 4 and all of them are radii. Correct. Why are they radii? Because they are starting from the origin and touching one point on the circle, right? So all of them are equal to 4. So what do I have here? 8 pi. So this is 8 pi, 8 pi, as it is 8 pi, and I have 1, 2, 3, 4, 5. 5 times the radius, so that is 20. So this is 20, and 8 pi is going to be 8 into 3.14. So this is going to be something like 24 point something, or more than 24. Here I have 20. Answer choice A. Right? Okay. Question 14. The total interest earned on D dollars invested for 3 months at 11% simple annual interest. Okay. So this requires you to know the formula, right? D is greater than 0, so that means there is a positive investment. Okay. So you see the formula is like this: P principal into the number of years, number of terms, okay, and the rate of interest. Okay, rate of interest in percentage. That is for 1 year. That is the interest earned in these many number of years. Okay. Now we don't have number of years, we have months, right? But this is simple interest, so no compounding, nothing. Basically how it works is that if it is 12% annual, That means 12% in simple interest for 1 year. Every month you are getting 12 divided by 12 because there are 12 months, 1%. First month 1%, second month 1%, and all that. So it's very, just divide that by number of months. Okay. So basically, what is saying? What am I saying? The principle here is D dollars. Number of terms. Number of terms is 3 months. Okay. Now I'm doing monthly rate of interest. I'm going to put, and rate of interest annual is 11. So monthly must be 11 by 12, right? Uh, into 1 by 100. Okay, because we are talking about percentage. Okay, is that correct? Total interest earned by D dollars, invested for 3 months. So 3 months I took, but I need rate of interest in months, which I did, and this is the percentage. Okay, so what do I get? I get 3 into 11 into D divided by 12 into 100. Okay, I will not simplify it because I have all these 11 300 terms, so I'll keep them as it is. I'll keep D as it is, I'll keep 11 as it is. Okay, uh, I'll get rid of this 12. So 3 by 12 is 4. 4 will come at the bottom. So 4 into 100. Okay. Right. So this is the expression that I get. What do I get? 11D by 400. And what do I have here? I have 11D by 300. Okay. So D is positive. Positive investment. It's an actual number, right? A whole number. So basically this quantity is the same. uh, let's say that is x, so I have x by 4 and x by 3, x being positive. Obviously, if I divide a positive quantity by a higher denominator, which is 4 here, I'll get a smaller answer. So this is going to be something small, this is going to be something big. That means answer choice B is the correct answer. Correct? This requires you to know the formula. All right, let's look at question 15. Y is greater than 0. All right, y is not equal to 1. Okay, is greater than 0, not equal to 1. So we will have to uh, look at cases less than 1 and greater than 1, right? uh, okay, we don't have to worry about negative numbers. It's fine. Root y square. Okay, let's take simple case. uh, let's take 36. Y is equal to 36. Okay, so this is going to be, root y is going to be 6, left hand side, right hand side, and y square is going to be 36 into 36. So this is going to be a big number, you don't have to calculate. The answer is going to be B if I take y as 36. Let me take a smaller number, right? Less than one number. Okay, because I have roots and squares, right? So the thing is, let's say this is I had 1, y is equal to 1. I'm not talking about this question, I'm talking about in general concept, right? For 1, square is also 1, root is also 1, right? So that's fine. But for any number greater than 1, the square goes away from 1. For example, if I take y is equal to 2, square becomes 4. So 2 is here, 4 is here, right? So the squares go farther and farther away from 1. But for numbers that are less than 1, okay, let's say number 0.81, okay, the square, oh sorry, let's take 0.9, okay, 0.9, okay, the square, 0.9 into 0.9, what is 0.9 into 0.9? That is 0.81, correct? 9981 and 1 decimal point plus 1 decimal point, 2 decimal points, 0.81. That number is less than 0.9. That's the logic here. Okay, so we'll have to take numbers less than 1, and that what happens there is that if y is less than 1, y square is going to be here on number line, okay, and y root of y is going to be higher than y higher than y. Okay, whereas in the other case, so let me 0 1, if I have y here, root y is here, and y square is here, right? But if I have y somewhere middle, I have root y here, y here, sorry, y square here, correct? So in both cases, I get a different relationship between root y square and root y. Okay, so that I don't know. Here I'm going to take, let's say again, we want to take a number. Let's take the same number, right? Let's take a number. We can take the same number, zero point 0.9, right? Uh, 0.9 square is going to be 0.81. That's y square, and root y is going to be somewhere greater than zero point 0.9, right? So something greater than 0 0.9. Let's say I write it as 0.9 plus, and this is 0.9 minus. Okay, so here what is bigger? The root is going to be, this was the root is going to be bigger. The answer is going to be A in that case. So I'm getting answer B in one case, answer A in other case. The answer is going to be answer D. This exact concept we have seen in other big book also. I think that was also a quantitative comparison question, very similar to this. Maybe in question test 2 or something, right? And I had explained the same concept there also, this whole diagram. Okay, so be mindful of that. Okay, let's move on. Question 16, 2 into 2 into 2 into 2 into 2. So that is 2 raised to 5, 32 divided by 2 plus 2 plus 2 plus 2. That is 2, 4 times 2 is 8. 32 by 8 is 4. Answer choice C. Which of the following is a multiple of both 7 and 13? Okay. Now 7 and 13, they both of them are prime. They don't have any common factor. Both of them are prime. So no common factors, right? So their multiple of both, that means the LCM will have to be 7 times 13, correct? So that will have to be 91, and its multiple. There is no other way, correct? So what is a multiple? Yes, this will be divisible. This is not divisible by 7. This is out. Let's, right. One thing, because I know that it has to be 91 and its multiple, the answer has to be 182, or twice of 2 times of 91. Okay. But other way also, what you could do is you can verify each number. This is not multiple of 7. This is also not a multiple of 7, right? This is a multiple of 7, but this is not a multiple of 70. 77 is not a multiple of 13. 156 is a multiple of 13. It's not a multiple of 7 though. 154 is a multiple of 7, so 156 is not, right? So that also you could do. But the easier logic, the sort of the correct math logic, is to find out the LCM and know that a number that's multiple of both will have to be a multiple of 91. There's only one number that's multiple of 91. So that's answer choice E. Okay. Question 18. Mario purchased $600 worth of traveler's checks. Okay. If each check was worth either $20 or $30. Okay. So let's say $20 he got X checks, $50 he got Y checks. Together, both of them cost 600. Right. Which of the following cannot be the number of $20 checks purchased? Okay. Now, whenever we have this cannot number, right, let's assume that it can. Let's say that we do actually have 10 $20 checks. Okay, and that will lead to some problem. Okay, so let's say if we have 10 checks, this is going to be $200 plus 50y is equal to 600, right? So 50y is going to be 400. 400 by 50 is going to be 8. So we have some solution for that, no problem here. Okay, that means this is possible, correct? So this is possible. This cannot be the answer. If I have 15 here, I'm going to get $300 of this plus 50y is equal to 600, correct? Again, that means 50y has to be 300, possible, right? What decides if that is possible or not? Y has to be a whole number. He's buying integer traveler's checks, right? So it has to be 1, 2, 3, 4, or it could also be 0, but it has to be a whole number. There is going to be one answer choice where it's going to be a fraction, the value of y, and that's what we are finding out. If this is c is equal to 18, so he is going to get, this is interesting. Okay, if c is equal to 18, 20x is going to be 360, 360 plus 50y is equal to 600. Okay. So 50y is going to be 240. Now I don't have a whole number solution for this. There cannot be a 50y which will add up to 240. Correct? A whole number y. That means this is not possible. Again, this is possible. You can verify for the sake of simplicity. Uh, this is going to be 400. 400 plus something is 600. 50y is 200. I can find that out. Again, here also this is going to be 500. 500 plus something 600. So that something is 100. 50y is 100. Possible. Okay. The only value where it does not work is answer choice C. Okay. Integer constraint. That's basically the concept here. Okay. If you change this advanced level stuff, if you change this to, let's say, something that can be a fraction. Let's say you bought sugar of two types, sugar and jaggery. $20 sugar and $50 jaggery per kg or per pound or something. Okay. And spend $600 together. In that case, 18 is also possible. Okay. The only thing is that you will have to buy jaggery, that is y here, in fractions, fraction of kgs, which is fine, right? You can buy, I want like 0.5 jaggery, 0.375 jaggery, any fraction you can buy of jaggery, right? But here you can't do that. Integer constraint, that's the concept. Okay, great, interesting problem. I don't remember, at least here in this set so far, that we have done any integer constraint question. So I like this question. Question 19, the figure above shows the floor dimension of an L-shaped roof. Okay, all angles are right angles. Fine, this is a proper room. If carpeting costs $20 per square meter, okay, these are all meters, what will be the carpeting cost? Okay, so basically I have to find out the area and then multiply that by 20. Okay, so let's see if I draw this so that I get two easy rectangles. What is this going to be? This is going to be 4. The whole is 10, so this is going to be 6. Okay. So this is going to be 6 times 4, that is 24, and this is going to be 10 times 4, that is 40. So total is going to be 64 square meters. Multiply that by 20 to get the flooring carpeting cost. So that comes out to be 1280. Answer choice B. Pretty straightforward. If there was a more complicated circle kind of a room, I think that would have been a more complicated question. Okay, question 20. If the value of the expression above is to be halved by doubling exactly one of the 5 numbers. Okay, interesting. So I need to double one of these numbers and I need to get the total value half. Okay, which number should be doubled? Okay, let's go logically. You can always take numbers also. Okay, easiest way to do is take numbers that are easy to work with. Okay, for example, take a is equal to 10, b is equal to 10, right? C is equal to 1, so that b by c becomes easy to calculate. D is equal to 10 and E is equal to 1. In that case, what would you get? You get 10 plus 10 by 1, that's 10, divided by 10 by 1, that's 10. So 10 plus 10 by 10, you get 2. Okay, now I'm going to double A or B or C, D, E and see if I get 4 as the answer. Okay, you could do it that way. That's very roundabout way of doing it. But if you do logically, I recommend that you do it this way also, right? But if you want to do it logically, what do I have to do? I have to double, right? And only one quantity. That means either I have to double the numerator or I have to, uh, oh, not, sorry, I don't have to double, I have to halve. Okay, so I have to halve. So that means, let's say n by d is the original number, okay? And I want to get some new number, let's say n1 by d1, right? But that has to be half of this, correct? Okay, so what do I have to do? N1 has to be, the new numerator has to be the original numerator by 2, okay, here, or D1 has to be 2 times the original denominator. Correct? Okay. And what are they asking? They are asking me to double something. Okay, that means it has to be the numerator that, sorry, denominator that I have to double. Okay, and there are two quantities in the denominator, right? D slash E. Which one will I double? I'll double this, because if I double this, right, then actually E is in the numerator only, right? Because denominator, it is in the denominator of the denominator. So essentially, if I simplify this, what I'm basically saying is whatever is the numerator, I have D slash E. Simplified terms, this numerator into E divided by D. That's what we have. Okay. So in most simplified terms, this is the expression that I have. Okay. And according to this logic, I have to double the denominator, so I have to double D. Correct. See if you get this logic, right? It's a little complicated for people who are not very familiar with numerators, denominators, and what happens if I multiply this, divide by this. Okay, and also half and double. Intuitively, also you need to understand this. Okay, if you didn't get that, you can always do it the basic way that I saw asked you, right? So there also, let's verify that D is the answer, even if you didn't understand the logic. Let me say D is 20 now. Okay. E remains same, this remains same, this remains same, this remains same. Okay. So the numerator is going to be the same 20. Okay. But denominator is going to be, instead of 10 by 1, it's going to be 20 by 1. Okay. That means it's going to be 20. Okay, so now the new value is going to be 1, the old value was 2, the value got half, right? So the answer has to be answer choice B. Very interesting problem. All right, let's look at the graph questions, questions 21 to 25. Health expenditures in the US 1970, sorry, 1950, 1979. Okay, only 2 years they have given. 1950 is represented by these. This is the 1950 series. Okay, the solid one, and the dotted one is 1979. Both expenditures are in billions. 1950, the total expenditure was 12 billion something. 1971, it was really big, some about 18, 19 times bigger than uh, earlier one. Okay, but here I have these expenditures given in percentage, right? So if you add all these up, you should get 100, and uh, percentages across different types of health expenditure. So hospital care was 40% of this 212 in 1979, or eyeglasses and appliances was whatever this 4% of 12.7 billion in 1950, that way. Okay, let's see the other graphs. Okay, I don't have other graphs, so only one graph with two series. All right, this looks pretty straightforward, but there may be some calculation here because the numbers are a little odd. Okay, anyway, doesn't matter. Let's look at the questions. For how many of the categories? Okay, so these categories, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, out of these 12, how many of the categories was the percent of total health expenditures greater in 79 than in 50? Okay, out of these 12, how many times do you have for any particular category 79 greater than 50? Okay, got it. So I have to go category by category and see where I have 79 greater than 50. Which one is 79 dotted? So I want dotted greater than solid. How many times? Okay. Here I have dotted greater than solid. So this is there. Here also, no, here I don't have dotted greater than solid. Here I don't have. Here I have dotted greater than solid. So 2 times. Then this dotted goes down, goes down, goes down. Here I have same, here I have same. Again dotted is down, dotted is up here, so that is 3 times. All right. Okay, let me just verify again in the reverse direction. Sometimes it helps if you do it in different directions. Okay, so dotted I want more, right? So dotted is more here, dotted is 1, 2 and 3. Correct. So I Did it twice. Answer should be 3. Answer choice B. Question 22. Of the following categories, for which was the percent of total expenditure in 1979 least? Okay. So in 1979, which category least expenditure? Okay. So the smallest number in 1979 is what I want. Okay, let me just get rid of this for simplicity. I want the smallest number in 1979. All right. Uh, uh, uh. What is the smallest number in 1979? These are all big numbers. The smallest numbers are these: 1, 2, 3, 4. Okay. Then I have the other numbers are fairly big. Okay. Uh, let's see, dentist services. Be very careful. Where is dentist services? Okay, dentist services is quite big, so that's not the answer. Nursing home care. Where is nursing home care? Okay, nursing home square is small, but that's the other series. Okay, be very careful. This is 1950 series. I'm looking at 1979. That's also big, so this is out. Drugs and drug sundries. That is 1979. It's fairly big. Government public health activities. Where is that? Government public health activities. Okay, that's there. Okay, I think this is a good answer choice. Research. Okay, now research versus government public. Obviously government public is higher than research, so answer choice has to be research. Answer choice. Let's see question 23. In 1979, how many of the categories was the amount of health expenditure less than $21 billion? Okay, they are asking for absolute number. uh, Amount of expenditure has to be less than 21 billion. What was the total expenditure? 212 billion. Okay, so 21 billion is what percent of 212 billion? Roughly 10%. Correct. So that means basically the question is, how right, this question, right? 79, how many of the categories the expenditure was less than 10%? In how many categories was the expenditure less than 10% in 1979? That is less than 10% is this. In all years, it was less than 10% in 1979, except these 2 years. Correct? Otherwise, this was less than 10. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct? 10 years. That is going to be answer choice D. Okay. Question 24. Approximately what was the ratio of health expenditure for hospital care in 79 to health expenditure for hospital care in 1950? Okay, so they're asking about absolute numbers. How much did you spend in 1979 versus how much did you spend in 1950? Take that ratio. Okay, let's find out that ratio. So that ratio is going to be hospital care. That's the first thing. Is going to be 40% of this. Oh, okay. Initially, I thought that 1950. Yeah, that's correct. Actually, 1950 less expenditure, 1979 more expenditure. Okay, yeah, right. Okay, I only got confused. So this is the solid number. Okay. Anyway, so I have to get 1979, right? 1979. Let me do it. Uh, Total was 212. I'm taking approximation, and 40% of that. 1950 was 12, and health care was 30%. What is this number? That's the ratio that I want. Correct. Be careful. Sometimes you tend to take the wrong number or reverse numbers. For example, I could have taken 1950 on top, 1979 and bottom, something like that. Don't do that. Be very careful. It can be confusing. So let's see. This gets cancelled. 4. This becomes 3. Okay. So what do I get? 212 divided by 9. 212 divided by 9. What's going to be? That's going to be something like 23. 212 divided by 9. Something like 22, 23. Okay. There's only one answer, that is close. Right? If you take the exact number, you will be able to arrive at this. Okay, but it's definitely not any of these. Correct? Because those are way off. right? Approximation works, and we have seen more complex graphs in earlier tests, and there also we have done approximations, right? Okay, question 25, which of the following can be inferred from the graph? The number of patients needing hospital care increased from 50 to 79. Okay, do I have anything about number of patients? All data is about dollars, expenditure and percentages and everything. If the expenditure is going up, that does not mean that number of patients is going up. Oh, I don't have any number of patients data, so I cannot determine this. I cannot infer this. The dollar amount of health expenditures for construction was greater in 79 than in 50. Okay, so let's find out construction. Uh, construction is this. So construction is what? Construction is in 1979. Let's me find this out. 1979, the construction was something like a 3% of 212. That's going to be something like very big, some 8%. I don't know. Let's say I round it off to 2%. That's going to be $6 billion, something. Okay. 1950 it was higher percent. This is 6%, right? So it was double 6%, but of a very small number, that is $12 billion. Okay, so that's going to be much smaller, whatever that number is. Okay, 6% of $12 million is going to be definitely less than $6 billion, because $6 billion is 50% of $12 billion, and I'm talking about 6% of 12 billion. So this is 1950 is significantly less. That's what I learned. What does it say? The dollar amount for health expenditure for construction was greater in 1979. True. Correct. I didn't even find out the actual number. That's not important. It was significantly greater. Okay, question. Statement 3. 1979. The dollar amount of health expenditure for dentist services, 79 dentists, was more than half dollar amount for health expenditure for physician service. So in 1979, is dentist greater than half physician? Okay, let's see if they are, how are they related? Is dentist greater than, dentist is what? 1979, that is this dotted line, more like 6%. 6%, half of physician. Where is physician? Physician services. Okay, physician services was 18, right? Dotted line, 1979 physician services. Okay. Was it true? 6% is greater than half of 18%. Is that true? No, that's not true, because 6% is not greater than 9. Correct? So this is false. One cannot be inferred, no data. The other is true, the third is false. How many can be inferred? Only one can be inferred. That's answer choice. Statement 2 only, which is answer choice B. All right, let's look at the next set of questions, next 5 questions. Question 26. If the perimeter of the rectangle above is 36, okay, this is going to be L, this is a rectangle, so opposite sides are equal. This is 4. So what is the perimeter? Perimeter is 8 plus 2L, that is given to be 36. That means 2L is going to be 28. L is going to be 40. Correct? Is that correct? If L is 14, so this is 14 plus 14, 28, plus 4 plus 4, 8, 28 plus 8 is 36. Okay, I'm verifying. I got the correct answer. Length is 14. L is equal to 14. Answer choice B. Pretty easy. If 4x is 6 less than 4y, 4x is 6 less than 4y, 4y minus 6, okay, then y minus 6 is what? Okay, I want y minus 6, so let me get 6 on this side, let me get x on this side. I get 4y minus 4x on this side, I get 6 on this side. I take 4 common, so 6 by 4 is equal to y minus x. 6 by 4 is 1.5, y minus x is 1.5, is answer choice D. Okay, you could have also taken some numbers. Let's say, for example, 6x is this equation, right? So let me say what would that number, let's say y is equal to 5. Okay, let's say y is equal to 5. So what do I get here? 4y is 20, 20 minus 6 is 14. So x will have to be 14 by 4 is 3.5. X is 3.5, y is 5. What is x minus y minus x? 1.5. Same thing. You would have got the same answer. It would have also worked for any other set of numbers also. Alright. Question 28. The difference between two positive numbers is 16. Okay, so let's say those numbers x and y. Y minus x is equal to 16. Alright. I'm assuming that y is bigger. Y minus x is 16. If the smaller of these two numbers, that means x, is 3/5 of the larger, x is 3/5 of y. Okay, then the value of the smaller number, what is x? Alright, let's solve this. So 5x is equal to 3y. Okay, here what do I get? 3y minus 3x is equal to 3 times 16. Okay, I just multiplied by 3. I substitute, what do I substitute? I substitute 3y as 5x. So I get 5x minus 3x is equal to 3 times 16. So 2x is equal to 3 times 16. I generally don't solve this because many times numbers get cancelled, so it becomes easy. X is equal to 3 times 16. It's not 3.16. Okay, it's 3 times 16. 3.16 by 2 is x is equal to 24. Right. So y is going to be what? Y is going to be 16. Just add 16 to that. Y is going to be 40. Are these numbers making sense? The difference between number is 16. Yes. Smaller of these numbers, that is 24, is 3/5 of the larger. 3/5 of 40. We have 8 3 24. Yes. This is the correct solution. What is the smaller number? Smaller number is 24. Answer choice B. Okay. 29. Let's look at question 29. 1 minus x into x minus 1 is equal to what? Interesting. One way obviously is to take some numbers and find out, let's say, what number would make sense. Let's say x is equal to 1. No, let's not take x equal to 1 because then it's going to be 0. And then, I mean, you can take, let's take x is equal to 1. Okay, so 1 minus x is equal to 0 into x minus 1. Sorry, 1 minus x is equal to 0, yes, and x minus 1 is equal to minus 1. Answer has to be 0. Let's see where I get answer as 0. Answer, I'll get 0 here. I'll get answer as 0 here also. 0 here also. Yeah, that's what my worry was. Here also I'm getting 0. Here also I'm getting 1. So it cannot be E. Okay, but let's take some big number, just a proper number, not a 0 or a 1 or something. Let's say x is equal to 5. Okay, so what do I get? 1 minus x is minus 4. X minus 5 is 4. So I should get minus 16 somewhere. Okay. What do I get here? Minus of x minus 1 square. So minus of 4 square, that is minus 16. Okay, this is good. X minus 1 square, I get 16. So this is not going to be correct. 0 is not there. X square minus 1 is going to be 24. 1 minus x square is going to be minus 24. Correct? So the answer has to be A. Right? You could also do it the regular algebra way. What you could do is 1 minus x times x minus 1, right? So let's multiply x minus 1 and minus x square plus x. So what do we get? You get 2x minus 1 minus x square. Now this looks complicated and none of these answer choices are given in that form, right? So this doesn't lead us anywhere. Then I'm forced to look at the answer choices, and I see that they are reverse of each other. Okay. So can I write everything in terms of x minus 1, because that's what is there in the answer choices. Okay. If I write everything in terms of x minus 1, I write the first term as minus of x minus 1, and then I have x minus 1. So minus of x minus 1 square. Answer choice A. Right? It took me a while because I was on the wrong track, because I thought that if I multiply, I'll get somewhere, but it got even more complicated. But then I was forced to look at answer choices and I could figure it out. You could do it that way also. Okay, let's look at last question, question 30. If a square is inscribed in a circle of radius r, okay, so this is a circle of radius r. Whenever a square is inscribed, the center of the square and center of the circle are the same, right? So this radius is r. These are obviously 90 degrees, okay? And this is a symmetrical figure. Then the area of the square region. So let's look at this small triangle. Okay, this is the square. Diagonals of the square intersect at 90 degrees. So this is r, this is r. Okay, so this is going to be root 2r, Pythagoras triangle, correct? This is going to be root 2r, which happens to be the length of the side of the square. Okay. So the area of the square is going to be square of that. So root 2r, the square of that is going to be 2r square. Answer choice E. Right? Pretty straightforward. All right, so that's the end of the test. Let's see any interesting questions or any sort of recap questions here. This was an interesting question. Can be done in multiple ways. The graph, I think, was pretty straightforward, owing to the fact that there was only one figure, one graph given. Okay, many times there are two graphs and then we have to juggle between two or three graphs. Uh, 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 this was a very interesting question, right? You could do it with plugging values, but logical way was easier. Uh, then I think these were very straightforward. This was, yeah, we saw a couple of answer choices D, so that we had to verify, right? And like I mentioned in the beginning, this particular question seemed to be a little interesting in terms of the mechanics of how the money is flowing. All right, so that's about it in this video. I hope you have been solving as we were going through these questions, because that's the only way for you to derive value from these videos. Don't just keep binge watching, because that gives you a false sense of preparation. You might think that you know it, but many times you meant to say answer choice A, but you click on answer choice B. Those kind of things happen. So it's only when you sort of solve these things, respond to these tests in a test-like fashion. That's the only way for you to derive value from these kind of videos. Not just my videos, any other videos also. All right. So hope you have been doing that, and I'll come up with the remaining videos. This is the 8th video in the whole GRE Big Book Quant series. So we still have the whole range is going to be 54 videos. So we have a lot, 46 videos more to shoot. So I hope you will go through all of that. Okay? Happy GRE.